But yeah, let's go ahead and kick off here. So thanks for joining. Great to see everybody in person finally. First reInvent in a while, so I'm super excited to be back in Las Vegas. My name is Paul Lacey. I'm a Senior Director of Product Marketing here at Matillion, and I'm here to talk to you about bringing universal connectivity to cloud data platforms. We're going to talk about what that means. We're going to talk a lot about some of the research that we've done here at Matillion, and we'll kind of run through some real-world use cases as well. So if you care about data, you care about getting data into your cloud data platforms, you have come to the right place. Let me ditch the mask. And we're gonna have some fun today. I'm joined by two colleagues of mine from Matillion as well. So Mark Balkenende, also Senior Director of Product Marketing. And I'm joined by Paul Johnson, who is the Director of Product Management for these kinds of technologies. So we got a really good crew up here to answer your questions as well. Let's go ahead and talk about our agenda. So we're going to be running through some of the challenges that exist in enterprise today. We'll be talking about some of the problems with trying to address these challenges with some of the legacy solutions that are out there, some of the tried and true type of design patterns and integration patterns, that sort of thing. We'll talk a little bit about what a new solution could look like, and we'll go into some detail in terms of what that is and how you might see that in your organization, how you might think about adopting a new approach. And then we'll talk about impact, right, which is why we're all here. We want to see this actually drive value in our business. So we're going to show you a real-world demo, hopefully, fingers crossed, that the internet starts working. If not, we'll show you a canned demo, which is the good backup, right? And we'll get a chance to see this all in action as well. So with that said, let's go ahead and dive in. Just a word about Matillion for those of you that aren't familiar with us. We're a cloud-native data integration platform, and we are built to support some of the most cutting-edge cloud data platforms that are on the market today. That includes Amazon Redshift, Snowflake, Databricks, and many, many more. We build our products to be cloud native, and we build them around what we consider to be the 4 key tenets of cloud native data integration, which is that products need to be easy to use today, that you can't be fighting with the technology when you're trying to get your job done, when you're trying to deal with the onslaught of data in enterprise context today. So we really try to make the software get out of the way, surface the right tools and the right options at the right moment, but otherwise, stay out of your way so you can get your work done. The second thing is we're built for the cloud. So we customize our products very deeply to each one of the cloud data platforms we support. And that goes well beyond just customizing for Redshift. We actually think about integrating with everything else that's in the Amazon ecosystem and Amazon service provider, service platform, so that you can take the full advantage of your cloud data platform of choice, and that's at your fingertips as well. We are built for the enterprise, and this is really in our DNA. When we build software, we think about enterprise data requirements, and we build around those from the ground up. And we'll talk a little bit more later on about what this means, but it's a core tenet to what we think about as the future of software. And then finally, we're built to deliver transformative value, both to our customers and to help our customers deliver that back out into their business with improved productivity and pricing models that are easy to buy and consume. So with that, I'll go ahead and turn it over to Mark Balkenende. Welcome, Mark.
Thank you.
Talk us through the problem.
No, I want that.
Yeah.
Welcome, everybody. Again, my name is Mark Balkenende. So I'm going to talk through some staggering numbers that we all deal with on a very daily basis to kind of set up why Matillion is tackling what we are. So data is everywhere. And if you think about just how fast we create data, in 2020, every human created about 1.7 megabytes of data per second. And this equated to about 2.5 quintillion, I think I got that right, bytes per day. That was a new one to me, quintillion. IDC did a study around the amount of data being created in 2020, and they came up with 64.2 zettabytes. Wow, I'm really struggling with my bytes today. Zettabytes of data, which is a ton of data, and they project it to be growing by 23% over the next few years. So data is just going to continue to grow. Data is being replicated to the cloud, being created in the cloud. It's just data is everywhere and growing quickly. And it is more dispersed and distributed with more sources than ever. So there's a lot of studies out there to talk about the number of sources that people in IT organizations and enterprises have to deal with. The average number of data sources per organization is around 400 different sources of data, different applications, third-party data, all those things. Where whoa, that was weird. The average data sources for the top 20% of enterprises is over 1,000 different sources of data for their BI and analytic programs. That's a lot of different sources that you guys have to deal with on a regular basis and keep track of, govern, have connectors, and all those things. Speed is essential, right? Getting fast answers to facts and business questions can be game-changing. When information changes, so does everything else. And informed decisions have a huge business impact. For example, the Fortune 1000 companies saw a $65 million additional potential net income by just giving more access to data, 10%, just 10% more access of data to their employees. They could track up to $65 million potential net income, and 60% potential increase in operating margins for enterprises that harness the full power of their data as well. Speed is essential. Analytic-ready data needs to get into the hands of the business users faster. So what are some of the complications? What's causing this, right? Enterprise SaaS is the ultimate driver for distribution, dispersed data sets, dynamic data sets, all types of things. We feel that enterprise SaaS applications are what's really driving a lot of this proliferation of data. The overall, if you just look at the numbers overall, the SaaS market growth between 2015 and 2020 was at 154%. And they project over the next 2 years now, we'll see if it's right, another projected 75% growth of those SaaS applications. Just the number of competitors in the SaaS market. So if you launched a SaaS application in 2011, you'd only see about 2 or 3 competitors in your space, in the space that you launched in your category. But over the course of the last 10 to 15 years, that has grown very quickly with the help of companies like AWS, making it easier to have a SaaS application. When you enter a new category, it's probably well over 10 different competitors when you get into that category. If you think about the benefits of the enterprise SaaS market out there, you have just a huge variety of choices, the customizations that you can make. There's thousands of SaaS applications. This is just a picture of the CRM market. How many CRM SaaS solutions are out there? Anybody have any guesses? 294 different CRM solutions options today. So Salesforce wasn't enough. We needed 293 more solutions for that. If you think about just the MarTech space alone, there's over 8,000 different SaaS products out there today. That's a huge amount of SaaS applications. Other benefits of SaaS is how fast you can bring those applications up. Pretty much, I always joke about anybody with a credit card in a business can start a new SaaS application. And then the IT department has to figure out how to report on it, govern the data in that. So it's becoming more and more difficult. But it's the speed, right? So 2007, I actually was doing enterprise analytics. And I argue that this 56 hours to bring up a SaaS or an enterprise application probably is pretty light. It took us much more than that back then. But over time, with the introduction of SaaS, you can start a SaaS application so much faster, so much easier. Like I said, with a credit card, you can have a SaaS database up and running, a CRM up and running. You can have data pumping between the two within hours. So even the 6.8 hours is probably, in 2016, has probably been cut substantially today. So how do you integrate? How do you get all this data? What are the options for you out there? So Matillion, we had a study done at the beginning of this year about what are the average connectors for your integration companies. The average number of connectors that integration companies today offer is around 125. I know there's some legacy ones that talk about thousands, but I can tell you how they do their math if you're interested afterwards. Find me. But if you think about that 8,000 SaaS MarTech SaaS applications out there, is much more than your 125. So there's a problem. There's a lot more sources, and they're coming faster than any integration company can handle. You could hand code them. So if you're on that low end of the spectrum on the slide I showed of 400 different sources, think about 4 to 6 weeks to build connectors average on a study that we found, where it takes 4 to 6 weeks to build a new connector for a source. If you have 400 sources, you either need a lot of people to build those, or some really fast people, or both. And then it takes a week, average a week, 1 week a quarter on each of those connectors to maintain them, to help fix any changes. Because a lot of SaaS vendors change the payloads, change the way, the layout of files, of the APIs, things like that. And you have to maintain those. Legacy integration tools were not really built for the cloud. Originally, a lot of the legacy integration tools were all on-prem. Now they've all started migrating to the cloud, but they're still constrained by the old paradigms, by some of their hardware-software dependencies, how they license, how they deploy, things like that. They're still in the old paradigm. They don't have the capabilities to do some of the point-to-point tunneling connections in the cloud that you need to go from on-prem to the cloud. They don't use the full design of the cloud either. They don't have the full capabilities of the storage, of the compute, the flexibility, the scalability that you get. They don't use that push-down capabilities to take full advantage of your cloud data platforms that you're on. And they just have limited integrations to other tools and other platforms that you need. Projects ultimately take too long and cost too much because it just sucks to deal with all these different sources and how much data is coming at you, how many different sources are coming at you. So at the end of the day, you need a better solution, something new. So Paul is going to come back on stage and talk about that. Thank you, Paul.
Thank you, Mark. All right. Yeah, so as we look over all these different solutions, or I mean these potential solutions that people have been trying in the past, right, it really does show you what the challenge is. And I think it also paints a picture of what we need in the future as well. So let's take a look at that for a second. You know, if we're going to try to avoid hand coding, and if we're going to try to avoid vendor dependence or vendor lock-in, how can we actually do this with the reality of thousands of SaaS tools coming into our organizations? Well, so the first one is we need to embrace universal connectivity, and we need to demand that from vendors as well. So we need to actually have a way of building our own connectors without using code for these thousands of SaaS API sources that are coming in. And we need to be able to empower our teams to move quickly with this as well. So being able to build SaaS API connectors in minutes is an imperative, and not relying on the vendors as well, right? Also making sure that it's within the skill set of our teams, right? How many people here are on a data team or leading a data team? See a few hands in the audience, yeah. How many people are developers in the audience? How many people are machine learning experts and data scientists? We've got a few, yeah. So just across that spectrum, we have several different domain expertise that we need to bring together in a program like this. We have different programming requirements too. So your machine learning expert might not be an expert in Java, for example, might not be able to write a Java connector, which is what a lot of the legacy solutions require us to do. And then you have to work with them to actually integrate that into their platform and get that running in their production system and environment, right? So it's just not scalable to think about having to write code to create connectors anymore. We need to move past that. The second thing is we need to have a unified experience across all these different data pipelines, right? So we just looked at the vast variety of the different sources that data is going to be coming through. What we'll talk about in a minute is different latencies and modalities of moving data between your cloud environment or between your sources and your cloud data platform. The problem is that the existing solutions they're siloed, and they're very specific to what they do. So you have batch data loaders and you have change data capture data loaders, for example. They don't integrate. There's no seamless experience. There's no single pane of glass where you can go and see exactly what's happening across all of your data loading activities and manage those at scale as well. So that's the second thing we need to look for, is unified experiences that are super easy to use. The third thing is we really need to look for technologies that are enterprise grade. We need the ability to run these in very complex environments, and we need to be able to support the regulatory, privacy, and governance requirements that are being pushed down on us, especially in an enterprise context. And that's one of the things that we've seen in our survey of the market as well, is that there's a lot of tools out there that were built for SMB type applications, and they were built around SMB style stacks because they didn't really understand the needs of enterprise, and enterprise was kind of dipping their toe in the water of the cloud, right? And migrations were just starting to get off the ground. Well, today, those migrations are in full swing. And as we start to move large volumes of sensitive customer information into the cloud, we start to realize some of the very real security requirements around handling that data and doing so in a responsible way, in dealing with the regulations that are increasingly being developed around the world in different geographic regions. And those of you that are here from an enterprise background know that you're going to be operating in multiple geographies, right? And so you need to be able to support those regulations, and you need a platform that's built that way as well. It's built to allow you to do that using modern type architectures like hybrid SaaS, which we'll talk a little bit more about in a minute, what that means, to separate the data plane, the data plane from the control plane, and having those two be separated with an air gap that gives you that high degree of security with the low amount of maintenance and a true managed service. So if these are the three things that we need to look for in a modern data platform, this was supposed to be a build, so apologies, but drum roll please. I'm excited to announce that Matillion is building one of those services in our Matillion Data Loader platform, and today we're excited to announce version 2.0 of that platform that's available for you to try right away, free of charge, under our public preview. You can go to dataloader.matillion.com and sign up and start using the service and giving us feedback on what you think about these newer technologies. We're bringing all of this technology to bear and trying to provide this to the market, because we believe that data loading needs to be a solved problem for the enterprise as well as it is for SMB. So that's one of the biggest things that we're here to talk to you about today. We're going to walk you through some real-world examples and use cases so you can see how you might be using this in context. And we'll talk you through some of the important features to look for in this or any other kind of an integration platform that you might like to build or purchase. So with that, let's go ahead and dive in. So the first thing is we were talking about having a unified sort of pane of glass, or one single source of truth for all of your data loading needs, and it needs to be super easy to use. Because one of the things we're finding more and more is that across the organization, there's more data sources, there's more people involved in the data integration process, there's more people who need to get access to data around your organization, and you want to be able to put this in the hands of just about anybody who wants to ingest data into the cloud data platform so that they can speed the process, right? And they can actually help you get the data in where it needs to be so you can start to build your downstream workflows off of that. So that's a big part of what we built. It's basically 3 steps to load for this product. And we really want to make this seamless and easy. So there's a lot of complexity in here if you actually want to dive in and configure things, but it gets out of the way if you don't need it. So you can really turn it loose with the rest of your audience across the enterprise and help them help you get data into your environment, right? That's super, super important. The second thing we talked about was building new connectors in minutes in a no-code interface. This is what it looks like. So we're porting some of the technology that we built in other parts of our platform into Matillion Data Loader, and in a wizard-based interface that lets you basically go through and configure a RESTful API with all the parameters and the headers and authentication and everything else. It walks you through the process of doing that without having to write any code. And that produces an output connector profile that can be then shared across your organization so other people can take advantage of it. Or you can publish it on the Matillion Exchange as well, where others in the community can download it and use it right away. So we start to see this flywheel forming around connectors, and we're seeing some of that in the open source community right now, but unfortunately it still requires a lot of code. All right, you got to fork those code bases to build your own connectors, or you got to apply to your connectors integrated with them, and you got to build them in code, whether it's Python or Ruby or some other language. What we're doing is we're trying to bring the no-code aspect of it into enterprise so that more and more people can start generating these connectors and sharing these connectors out across the ecosystem as well, so that we start to pick up some real efficiency and speed with this. Because if we're going to try to get ahead of 1,000 different data sources in your enterprise analytics, we're going to have to allow you to build those connectors and build them at speed, and then harness the work that's being done by others in the community as well. So that's a big part of it. The third thing is that when we say enterprise grade, we really do mean enterprise grade by design. So when you want to purchase enterprise software, you want to know that it's reliable, trustworthy, that it's doing the right things with your data, and that it's giving you the right control over security of your data as well. So we think really deeply about things like SLA guarantees, making sure that the service is reliable, you can count on it to be there when you need it. We think a lot about API-based automations and bringing bringing the ability for you to trigger transformations on the fly, or trigger basically integrate this into other parts of your stack, right? Your data loader service needs to be at the service of other parts of your stack. So being able to integrate that is really important. VPN-based tunnel security, we talked about this, and Mark talked about this a little bit in some of the challenges or shortcomings of legacy technologies. We're in the cloud, but that doesn't mean our data needs to be on the cloud, right? There's lots of applications where we want to be sending this via private connections, SSH tunnels and stuff like that, so that when we move massive volumes of data, we don't become a target of malicious actors. And so when we do that, we're basically opening up the ability to handle customer data safely and securely. And finally, I said we talk a little bit more about hybrid SaaS. So what we're seeing now is kind of the best-in-class architecture for enterprise-grade security is this ability to operate on the data using agents that run in your own virtual private cloud or your own virtual instance of the cloud, and then they communicate back and forth to get their instructions and their runtime instruction sets from a SaaS service, which is where you design your logic, but that they don't communicate with each other than that. So it's a highly secure way of processing massive amounts of data in an enterprise context. So you can actually have that data live within your system, and it never leaves your system, never leaves the walls of your own firewall, but you can operate on it using a managed service like a SaaS interface. Really gives you the best of both worlds, because you can upgrade those agents remotely, you can manage those agents remotely, and you can take advantage of all the benefits of hybrid SaaS or a managed SaaS service without passing your data through servers that you don't control in areas of the world that you might not want your data to be landing as well. So that's a big one as well. Okay, so we've talked a lot about data loading. Now let's talk a little bit about a new kind of data loading, or rather a version of data loading that's getting a lot more popular these days, and that's called change data capture. So change data capture is it's the act of being able to replicate your data from an operational context into an analytics environment, right? And one of the things that we're seeing more and more across Matillion's customer base is that people are actually starting to use their Redshift instances, their Snowflake instances, as a backend for some of their operational systems. As they're starting to realize the value of their data, and as they're starting to realize the power of being able to combine your data in the cloud, enrich it, create these really unique and powerful data sets, they realize this goes way beyond analytics and BI, right? This goes into machine learning and data science. This goes into operational analytics. You can actually automate your business on some of the data that's in your cloud data warehouse today. And people are wanting to do this, right? They're actually wanting to push the data back out into their organization in various contexts and start using it, start harnessing it. But in order to do this, they actually need to have really low latency ways of ingesting real-time information and acting on that information in their cloud data warehouse, right? Something that we know very well in an application context, but is relatively new in the analytics context when we start to think about bridging beyond just a cloud data warehouse as a source of dashboards and BI. So it's a growing requirement for enterprise, and it's a really unique one too, where traditionally a lot of the players have just focused on mirroring tables from one source to another, which is what you'll find is 90% of the market today is you can take a snapshot, or you can have an agent that feeds off of the logs of your operational database and mirrors that table bit for bit, essentially in a Redshift or Snowflake environment. You can feed off of that data for your downstream transformations. You can build some really sophisticated things off of that. But that only goes so far, right? That only is just replicating a point-in-time snapshot of your data into your database. What about all the stuff that happens in between, right? What about all the events that happen on your database, the rich events that you could harvest and use for other types of contexts as well? So we're going to get into that in a minute. We'll talk about some of those unique use cases that can be unlocked when you go beyond replication with change data capture. The next thing is full ETL integration, and this is also a big shortcoming today, and we've heard from a lot of our customers, is sure you can refresh your data in a landing zone in your data warehouse, but then you need to transform it and get it ready for use, right, in different enterprise applications. And that means transformation logic, that means ETL workflows that need to be triggered, that means aggregations and other types of data synthesis needs to happen, data cleansing, to make this data ready and usable in an operational context. And for that, you really do need integration with downstream ETL workflows. The challenge is that a lot of data loaders exist in a silo today. They don't really talk to the ETL layer. They don't kick off ETL transformations so that your data flows and refreshes through your system all the way from start to finish, and create these rich data sets that you can then use to power your enterprise analytics and beyond, your enterprise operations. And finally, we need to have systems that are easy to set up and manage as well. And we talked about this before. You can't, there's so much complexity in the enterprise today, and there's so much demand for processing data, and there's such scarcity in the skill sets to do so, that we can't be involved with managing infrastructure anymore. We have to get out of the business of managing infrastructure and building these things by hand and having to maintain them as well. Like Mark was saying, it takes 4 to 6 weeks to build a connector, but did you notice it's a week per quarter to maintain it, right? And that's a huge time sink for a lot of organizations, a lot of data teams today. So those are some of the most important aspects of CDC streaming and what modern solutions look like around CDC streaming as well. So let's talk a little bit about each one of those. I want to show you some architectural diagrams. Here's a simplified one on how we work with data that goes beyond just CDC replication. So a lot of replicators out there will kind of just focus on taking a snapshot of your operational data set on the left and kind of replicating it through to the right in some sort of an analytics database like a Snowflake or a Redshift or that sort of a thing. When we talk about going beyond replication, what we're talking about is storing that change log in a data lake environment where you can actually query it and use it in an analytics context, right? And that query log becomes really important because it unlocks a tremendous amount of use cases. You can actually start to train machine learning models off of that event stream. So you can turn your database into an event stream and train your models to feed off of that event stream rather than just snapshots in time of your data sets, which is super, super powerful. Another thing you can do, which is my favorite, is fraud analytics, fraud detection. In many cases, in a fraud context, the changes that are made by a malicious actor are very transient. They can happen in a matter of seconds, matter of minutes, where they'll change something in order to gain access to a system, and then they'll flip it back in order to cover their tracks. And if you're just relying on a snapshot-based approach of replicating your data, and that frequency of those snapshots was below the latency of their changes, the transient changes they're making, you lose that information entirely. But if you capture the logs and you capture the events as they happen, and you can query across those events in sequential order, then it unlocks the ability to be able to detect those things either in real time if your system is developed to do that, or in retrospect as well, and you can decide what you need to do about that breach. But anyway, it unlocks a ton of use cases like this to be able to have more rich data available. And it's just one example of how changing the way that you load data can really change the way, the potential for harnessing that data within your enterprise environment and within your analytics context as well. The last thing that I'll talk about, and then we'll talk about an actual demo, and fingers crossed that the internet is back. Otherwise, we'll be looking at a fake demo, which is just as good, is full integration from end to end with your data loader and the rest of your platform. And this is something that I think a lot of people overlook right now because they're not aware that this is going to come back to bite them later on, and especially if they're early in their cloud migration journey. We really need the data loader to be a part of your system, to be a citizen of your full stack, such that when your data loading is complete, it can trigger downstream ETL transformation jobs that pick up that data and make it useful in your enterprise analytics stacks and beyond, and actually pushing it out into beyond the analytics stack as well. So you really need that full process automated end to end. You can't just have a data loader that just leaves the data somewhere and then you're based on some sort of time-based trigger or something else to know that data set's been refreshed and to go in there and to drive the transformations that need to happen downstream from that. This needs to be seamless. It needs to be as quick as possible. And vice versa. You actually need your ETL layer to be integrated with your data loader so you're not repeating yourself. Right? That's one of the concepts of programming is don't repeat yourself. We don't want to repeat ourselves in the data pipeline space as well. So we don't want to have to rebuild pipelines in our ETL layer just so the ETL tool has control over them. We actually want the data loader to be triggerable by the ETL tool. So the ETL tool can go out and say, give me a refreshed data set. I'm going to do some work on it. And then that actually happens. The data loader loads that data, and then the ETL tool can take over and do all of its processing as well. So some things to think about when you're thinking about what kind of a data platform do you want to adopt, or what kind of a data platform do you want to build using all the different services at your disposal, thinking about how it needs to be integrated, thinking about how it needs to be real time, and thinking about the potential of getting more of this data into your organization as well, so that you can start to drive some more operational processes with it. And with that, I'd like to invite Mr. Paul Johnson to the stage to see if we can do a demo.
So I hope everyone did have their fingers crossed. We'll see. Have a look. I think we might be out of luck.
All right. Not to worry, we were prepared for this eventuality. So let's go ahead and switch over then. Paul, I don't know if this is going to narrate for you or
Well, if
or
there's,
what.
let's see if the audio comes up. Otherwise, I'll speak over the video. But let's have a quick look.
Actually, I don't know that. Oh, we've already switched, so that means we need to switch back.
And in MDL, there are two types of
There we
data
go.
pipelines that you can create. We have batch loading and we have change data capture. And I'm going to show you both of these and why they're both important, but for different reasons. And to do this, we're going to take a quick look at an order process for an online retailer. We've all used Amazon before, so I'm pretty sure we can imagine what this kind of thing looks like. But this is a real order process from a Matillion customer that I've used some creative license just to simplify it a little bit. So you can see here that orders get placed, some fraud checks happen, some approval happens there. Orders are approved or declined, orders are shipped and delivered. And each of these green statuses relates to the order status column in the orders table. Now this is important and we'll come back to that later, but just keep that in your mind. So now imagine that you're responsible for reporting on this order process. Let's say you need to be able to answer the following questions. How many orders were there yesterday? What was the total revenue generated? What was the average price per order? How many orders were cancelled? And what was the top selling item? So what we need to do in this case is to query that orders table, extract and load the data once a day or once an hour or however long we want to do that, and then build a report to aggregate those results. So let me show you how we can do that extract and load inside Matillion Data Loader. Okay, then let's create this pipeline. So I'm going to select batch loading as my ingestion style, and my orders table is in my Postgres database, so I'm going to select the Postgres as my source. And the first step here is to connect to that database. So I'm just going to pop in some connection details that's going to allow me to connect to this database, and I'm going to reuse a password that I've already configured as part of Matillion's secure password manager, so I can reuse these passwords between the two pipeline types. Hit test and continue. Everything's good there. So now we're able to choose our schema and the tables within that schema that we want to copy over as part of this pipeline. To keep things simple, I'm just going to use the demo schema with my single orders table and continue with that. And now I need to configure the columns for this pipeline. So if I click on configure, there's a couple of things I need to do first. So first is the primary key. Matillion Data Loader has already suggested to me that it could be the order ID or the ID column. So I could use both if it was a composite key, or I could deselect the order ID and just keep the ID. The second choice here to make is the incremental column. So the incremental column is how we decide what the delta will be between the two pipeline runs. Now usually this is a date time field, but it can also be an incremented integer column as well. I'm going to choose the last updated timestamp column. And then finally I need to decide which columns I want to include as part of this pipeline as well. So I'm just going to go in here and remove any that might contain any PII information. So I'm going to get rid of the name and the address columns and click done, and then continue. So next I'm going to choose the destination. Now I've already configured Snowflake and saved that as a destination, so I can reuse this in any pipeline. It's got my defaults already set, and I do have the option to add a table prefix So if I want to distinguish the Matillion data loader tables in my warehouse from regular tables, I can put a prefix as optional there as well. I'm going to continue and then set a pipeline name. So we're going to choose the orders as the pipeline name, and then we're going to set this to run once every day. So that pipeline will begin in just a moment, and then it will run once a day from there on. And we do have some options to do some more advanced scheduling as well. But you can see it's starting to set up now. I can go back and edit this pipeline or remove it if I need to. But in a few moments time, my orders data minus those columns that I selected will be replicated over into Snowflake, and then once a day it will go and capture the delta. Okay, so revisiting this order process, you can see there are a lot of different statuses. Each change in status is an actual event that happens. In the technical terminology, this is what's called an immutable fact, and they have meaning and they have relevance for analytics. And in case of fraud analytics, you want to be able to answer the following questions. How many of my orders were cancelled because of fraud checks? What percentage of the orders were automatically approved? How many were manually approved? Or perhaps how long does it take for a fraud check to be completed? Now imagine we tried to answer those questions using the data that we've just loaded in that MDL pipeline. Well, let's consider a moment how that works. So with MDL batch, we have a snapshot point in time of the source database that we're extracting. And each subsequent load, we're taking another snapshot, which is the delta between the two times. If we're doing this once a day, or even once an hour, the status of an order will be whatever it was at the point in time we did the extraction. But what we actually need here is every change in status that happened between those two pipeline runs. Now to do that, we need change data capture. Specifically, we need log-based change data capture. So instead of querying the database, we monitor the transaction logs. So we're able to replicate each change as they happen, and importantly, the order that they happen. And we store this in a persistent history in a data lake for use in our analytics use case. Now, typically this is a much more advanced and difficult process to get set up, but let me show you how easy that is with Matillion Data Loader. Setting up a CDC pipeline is very similar to setting up a batch pipeline, with one major difference. CDC pipelines first involve configuring an agent. An agent is a container that you install in your own network, either on-prem or in the cloud, and this ensures that all data movement stays behind your firewall. Now you can see I've got two agents, one that's connected and one disconnected. Once you have the agent installed, you then need to connect it to the Matillion platform so they can receive the instructions and start replicating the changes over. This process takes about 5 minutes, so I've deployed my agent via Amazon ECS in this example, and I've connected it to the Matillion cloud. The next step for me then is to create a pipeline with that connected agent. And as before, I'm going to use Postgres as my source database. I'm going to give this the name of the orders. I'm going to populate the fields to connect to that database. Now, the difference this time is instead of me passing in a password in that connection through Matillion's password manager, when I deployed my agent, I gave it access to my secret manager. So we support Amazon Secrets Manager and Azure Key Vault. And what this allows me to do is retrieve a password from that Secrets Manager instead of passing it through the agent itself. So I'm just going to populate the secret name and the secret provider and then hit test and continue. And here I'm able to now, as before, select the schema and the tables that we want to choose to replicate. So we're going to use that orders table, continue with that one table, and now we're going to choose where we're going to replicate those changes to. So this is going to be my Amazon S3 data lake. I'm going to choose that as the target, give it a bucket name, and optionally I can choose a prefix here as well. So I'm going to give the prefix of demo test. There are no advanced settings that I need to populate, so I'm just going to go ahead and create and start that pipeline. You can see there's my pipeline created, and it's in streaming mode right now. So that means changes are being picked up as they happen on the source database and being replicated over into Amazon and S3. Of course, replicating the data into a data lake or a lakehouse architecture is only really the first step. The next step is to take that raw data and turn it into some analytics ready data sets. For the final part of this demo, I'm going to show you how the CDC process integrates with our enterprise data transformation product, Matillion ETL. So first, let's just take a look at the raw data that's currently being loaded into S3 by that CDC process. So I can actually sample this through the use of an external table, and I can see in there we've got the semi-structured data with some metadata columns as well. So just having a quick look here, I can see that this record is a create operation. There's obviously no before data, it's a null before they create. And after they create, we can see that an order was placed and all the associated details with that. This is great that we've got this persistent history in our data lake, but for making it analytics ready, we need something that looks a little bit more like this, some highly structured data. So how do I go from the raw data to the structured data? Well, we ship with Matillion ETL some pre-built components that allow you to do this in a couple of seconds. So the first thing that we need to do there is create that external table. And if it already exists, then we need to refresh that external table to pick up any changes. So we have a component that does that called create or refresh external table. So I'm going to configure this for you right now. There's some target details and some stage and external table names that we have to populate. So I'm just going to make sure that these details are correct. My external table name is correct as well. So after we've created or refreshed the external table, we need to pick up those changes and then replicate them into our internal tables. So if you're using a single table like I am, you'll use the sync single table component, or if you're using multiple, you'll sync all tables component. The important thing to note here is, along with the source and target metadata that we've been populated, is the transformation type. So we offer 3 different types of transformation that can happen at this stage. So number 1 is copy table. This is a basic replication use case where your target table will look exactly like your source table. Option 2 is the same as before, but with soft deletes. So this means any deleted records in the source do not get deleted in the target, but they get flagged as deleted instead. And then the final option is the change log. So this is the one that's important to our use case today. So those earlier questions around how many manually approved fraud events would happen, for example, you'd need the change log to see all of those different events. So that's the one that I'm going to choose here. I'm going to include the metadata as well. So there was an option to choose any metadata columns to get appended, or only the ones that are required as part of the transformation. I'm going to choose to use all of them. Now when I run this job, which I will do in just a second, I should see that any orders that were existing before should get appended onto that. So my current row count before I run this job is 5.174 million records. So I'm going to run this job now, and as I described, what will happen is we'll refresh the external table, and any events that have been captured and replicated by the CDC pipeline in the time that I've been talking should then be available for us to use. Once they're available, that sync single table job will then go and flatten that semi-structured data and turn it into that target table. So that job is now completed, and if I just come back onto my orders structured table, hopefully we'll see this row count go up if any changes have happened. And you can see it's gone up by a few thousand records. So in that time that we ran that job, a few thousand more events happened. And I can see all of that structured data and all of the events that happened in between as well. So we can see all the manual, automatically approved, and cancel payment events. So that allows us to answer those questions that we had earlier on. So that was a first look at Matillion Data Loader 2.0. It's currently in preview, and if you would like access, you can sign up through matillion.com.
All right.
Good.
Thank you,
Yeah.
Paul.
I'll hand back to Paul after that.
That was a very smooth demo, sir. Well done being prepared for no internet. You got to prepare for everything these days. Awesome. Yeah. So that's a good look at sort of how you can see this running in real time and seeing this apply value across your business. So let's summarize this, and then we'll open up the floor for questions. So we talked about all the different challenges that enterprises are facing today with the number of data sources coming at them and number of SaaS, enterprise SaaS applications you've got to integrate into your platform today, and the fact that you just can't keep up with that if you're doing hand coding or you're relying on someone else to do that and as a gatekeeper for you. So we really do need a new solution, and that's what we're bringing to market with Matillion Data Loader version 2. But let's also talk about some of the value that you can unlock in your business if you're able to get ahead of this challenge as well. So the first one is you can really get out of the way of your organization adopting new SaaS platforms, right? And as there are a lot of us in here who think deeply about IT infrastructure, and we think about analytics and the need to bring data in from all these different data sources, some of us can cringe when we see numbers like how fast it is to onboard new SaaS products into our business, and the fact that probably in the amount of time we've been sitting here just now, there might have been a new SaaS product that came into your business somewhere, right? That you have to go home now and at the end of the week and support. And so being able to do that at scale and speed is really, really crucial. It allows you to get out of the business of being the gatekeeper of your own organization, telling them which platforms they can and can't adopt, because there is tremendous benefit in adopting these new SaaS technologies and allowing your organization to be able to do that while you still are able to do your analytics and get the data out of those platforms and into the places it needs to be across the business. So that's the first thing. The second thing is we talked a lot about the new types of data products that you can create, the new types of applications you can unlock in your organization when you have this data at your disposal. And when you're able to enrich this data and create these new rich data sets that can be externalized or provided to internal customers as well to provide game-changing value to your business, right? So we really start to see the potential of data as a service type applications coming together when you can bring all this data together in a platform like Amazon Redshift. And finally, accelerating the value of your analytics, right? That's what we're here to do at the end of the day is get things done faster and more efficiently with data in our businesses. And when you're able to free up developer time from maintaining pipelines or building connectors or things like that so they can work on higher level things in the business, you unleash tremendous value in your organization. You really let your team move faster as well. So that's been a quick summary, not a quick summary. It's been a good overview of what the market is for data loading products today. What are some of the challenges that you might experience when you're trying to bring data into your cloud data platform of choice, and some of the techniques and things you might consider to overcome that as well. So with that, I'd love to close out and open up for questions. We've got just over 10 minutes left to answer any questions that you might have. We'll start with right down in center. We don't have a microphone, unfortunately, so we'll repeat the question for those that are streaming in online. Yeah. Excellent question. Paul, do you want to address that? Can you repeat the question as well, please?
Yeah, so I'll try and paraphrase, but there were some things in the demo that you potentially saw as attack vectors, and what kind of mitigations do we have, and there's a specific thing about SOC certification as well. So Matillion is SOC certified, and these new products will be as well as part of that. In terms of the security aspect, so you saw things like Matillion's password manager in the first part of it. So any passwords that we store are encrypted in transit and at rest, and end-to-end encryption on those kind of things. And in the kind of the hybrid architecture one, you saw we accessed AWS Secrets Manager. So what we do there is when we install the agent, we give it the AWS role permission to go and access those. So all the security is managed by the AWS role management system in that case. So we're not doing anything outside of what you might expect in that sense. We're just saying this agent has permission to go and look at certain secrets in the Secrets Manager, We just give it the name, and then it goes and retrieves them securely. So that means that the control plane and the data plane, and the only kind of communication that goes across there is basically kind of metadata and instructions that go. So we say, right, here's the config that you need, here's where you go to get the data, and here's where you need to put it. And the agent itself goes and gets what it needs then to do that. And that's why we mean when Paul says there's an air gap there, it really means like no data goes through a Matillion server in that scenario. We don't even pass credentials through because they're in the AWS infrastructure already. So does that answer your question? So we do, some of the metadata is stored in the cloud. There's no kind of like PII or any customer data or anything like that. It's just, here's what the agent will need to go and do its thing. So you could destroy the agent, spin up a new agent, and it would call back to the cloud and get all of the config that it needed, and you could go again. But the kind of the blast radius of that agent is contained there. So only that agent can connect to that database because it's received those instructions from that agent, from the platform, sorry.
Good questions, thank you. More questions right down in the back.
Yep.
Good questions, yeah. So Paul, would you summarize, please?
Yeah, so how do we cater for kind of schema drift, which happens? That was the first part. And the second one was, what's the commercial model, was it? Yeah. So do you want to take the second part? Or do you
Sure,
want,
yeah.
Okay. So how do we handle schema drift? So in the Matillion data loader pipeline, you didn't actually see it. It was kind of transparent. But behind the scenes, the logic that's happening there, it has this kind of schema drift capability built in. So if a new column gets added, for example, the pipeline doesn't break, it just gets picked up, and in that table that gets staged, you'll have the new column there. If a data type is changed, we'll create a new column with the new data type, and all the new data will get populated in that new one. The old one will still exist, we'll just put null records in there. So if you wanted to create a view at the end of it, and you could create like that unified view. And there's a few other examples like that where it's kind of baked into the logic behind the scenes. What Paul was saying earlier about just the complexity just getting out of your way, we just want to really focus in on like making it as easy as possible to do that. All the complexity is handled. And there are some certain things in the product where you can expose this. You can turn on like the advanced mode and you can open up some extra parameters, but we just, by default, we kind of hide that. And if you do have that kind of advanced use case where you need to go and tweak a few things, you can open up the advanced mode and put some parameters in and say, right, well, maybe I just want to be notified in this case rather than actually carry through the change. So it's kind of, the complexity is there, but we kind of just really simplify that initial journey. When someone becomes like a power user, as you might say, then you could turn on the advanced mode and have access to these parameters and things. Do you want to mention the commercial model a little bit?
Yeah, I'll talk to that just briefly. So we at Matillion, we care very much about providing value to our customers, and we also personally dislike shelfware, and we hate it when we impose that on our clients or customers as well. So we have a usage-based pricing model across all of our platforms. And there are enterprise agreements and arrangements you can enter into in exchange for discounts and things like that. But at the end of the day, we want you to get incremental value from these platforms as you're processing data. So there's no large upfront outlays of cash. It's a pay-as-you-use model or pay-as-you-go model. That applies to both Matillion ETL and Matillion Data Loader as well. We have a concept of a universal credit in Matillion world, and so you can actually purchase credits that you can use in both products, and you can kind of transfer them back and forth. So, the data loading product will be consuming credits based on the number of rows moved whereas the ETL model is a little bit more based on hardware because we're doing really robust transformations and things like that in there as well. So it more towards the CPU hours and things like that. But the core concept is that you shouldn't be paying for software that you're not using, and that we set up our business model in order to help you get incremental value very quickly, and the cost scales with the value that you're getting. Does that make sense? Does that answer the question?
Another
Perfect.
question over here.
Question over here. Yes, please.
Yeah, so I've got two questions, both about access to the network. So one is, for the no-code solution, is there a way to get at the code if I want to be able to manage that with Git and Kraken? And then another internal question is, if your diagram you showed the CDC solution going directly to S3, I don't know if you have a queue in the middle there, like that would be the kind of classic architecture, is you stick a Kafka in there and then you have Kafka right to S3, and get that really the way it works, do I get access to the queue?
Perfect. Yeah, Paul, if you could just summarize, please, and answer the question.
Yeah, so, sorry, just the first part of your question, because I was focusing on the Kafka part there. So.
The first part is the no-code, right?
Right, yeah.
No-code to me is actually a downside, right? Like, I want the ability to manage things to Git, I want Git blame, I want control to converge to page.
Yeah, so in our transformation tool, which you saw at the back end of the demo there, we have that fully integrated with Git, so you can have different developers working on different kind of branches of the job, and you can merge them together and promote them through environments and stuff like that. And right now in the data loader product, because there's no code there, it's kind of just the wizard-based stuff, there's no need for that kind of Git integration. However, there will be kind of environment-based promotion of the jobs that you're building and stuff like that. So if you can go from a development pipeline, even though there's no code in it, you turn that into a production environment, you still want to have this very similar kind of workflow. So we're building that kind of stuff in. And the second part was on the CDC architecture. So it does replicate to S3. So our agent, what it actually does is reads from the change log. It doesn't matter what database it's coming from, and it formats the payload, if you like, so it's standardized. So if you took a SQL Server and a Postgres and a MySQL, they have different kind of logs. They look different. By the time it gets out of the agent, they're all standardized into that kind of that view that you saw in the data lake. The next step onto that would be, well, potentially you could put it onto a queue, onto a Kafka topic if you wanted to. It's not in the product right now. We're only in the public preview, but a future roadmap is to support Kafka for that. We also have kind of other message-based queue. So SQS is a good example. So you might put something into an S3 bucket. An SQS message might trigger your ETL job to go and start from that. I think there was a question over here.
Unfortunately, I think we have to cut it short.
Oh, okay.
Yeah, we're at time. So, yeah, well, please come up and ask us more questions. We're also here in the trade show at booth 530 if you want to come ask some more questions of us as well. Thank you so much, and thanks for coming out for the first in-person reInvent in a long time. Great to see you. We look forward to continuing the conversation. Those of you that are interested in signing up for the preview can actually do so by scanning this QR code that's up here on stage.
There's one back by the door, too,
and there's also one back by the door on your way out, so sign up for that, and that'll get you to the right place. And also just quick plug to please fill out your session survey. That's how we learn as presenters and how we can get better in delivering more content for you. And so we really appreciate if you could do that as well. So thank you, everybody. It was great talking with you, and we'll see you at the show.
Thank you.
Thank you.